Hello. Now we are going to look at solving probability questions using tree diagrams, and particularly tree diagrams where we draw out the probabilities on the branches of the tree. And we'll jump into an example. A biased coin is flipped 2 times. The probability of getting a head is 3/4. So it's an unfair coin. I should have a probability of a half if I had a fair coin for getting a head. Now I have a probability of 3/4. That means that it's biased towards the probability of getting a head. So what's the probability of getting a tail on this biased coin? Well, instinctively we might say 1/4, but we have to be able to tell the story of why. So the probability of getting a head plus the probability of getting a tail must add up to 1. Why? Because the probability of 1 is certainty, and I'm certain when I flip a coin that it's either going to land on heads or it's going to land on tails. In probability questions, unless they particularly tell us to, we don't take into account strange cases like the coin landing on its edge. We say that it either landed on heads or it landed on tails, and those are the only possibilities we take into account. So if we add up the probability of getting a head and the probability of getting a tail, we have to be certain that we're going to get one of those outcomes, so that means that we have a probability of 1. So if we add up all our possible situations, we have to get a probability of 1. In this case, I know the probability of getting a head is 3/4. Plus probability of getting a tail is 1. I want to know what the probability of getting a tail is, so I'm going to rearrange my equation here. So this is effectively just finding x, even though p of t, probability of tails, looks a little bit more abstract. It just is an unknown. It's 1 minus 3/4. 1 is 4/4 minus 3/4. So when we do out the sum, I don't have space here, but when we do out the sum, you would end up with 1/4 for our probability of getting a tail. Now to our tree diagram. So if we start off and we haven't done anything yet, we flip our coin for the first time and we could get a head. Or we flip our coin for the first time and we could get a tail. Those are our two possible outcomes the first time we flip a coin. And the probability of getting a head is 3/4. And the probability of getting a tail is 1/4. So we write those probabilities along the branches of our tree. But then we would be able to flip the coin a second time. And we could get a head again. Or we could get a tail this time. And if we got a tail the first time, we could get a head the second time. Or we could get a tail the second time. And the probabilities would be the same again. There's no change in this case. Probability would be 3/4 of getting a head, 1/4 of getting a tail, 3/4 for getting the head, and 1/4 for getting the tail. I might make that a little bit bigger there. 3/4 for the probability of getting the head. So here, we hadn't flipped the coin yet. The first time we got a head, and then the second time we got a head. So here, we got a head and a head. Here we got a head and a tail. So we use our tree diagram by walking out the branches to find our different outcomes. So we got a tail the first time, a head the second time. A tail the first time, a tail the second time. And those are our different possibilities. So as so often happens, the tree diagram also gives us our sample space, our list of possible outcomes. But now it's also going to help us with working out the probabilities. So what is the probability of getting a head and then a tail? So let's see what meets that criteria. We want to get the probability of a head and then a tail, or putting that into more direct English, what's the probability of getting a head and then a tail? So what meets that criteria? Well, we have to get a head the first time and a tail. So we have to go head, then tail. So 3/4 of the time when we flip our coin, we get a head. And then 1/4 of the time we get a tail. So if we think about our possibilities, 3/4 of the time we get a head, and then 1/4 of that 3/4 of the time we're going to get a tail the second time. So 3/4 of the time we could get a head, and then 1/4 of that 3/4 is the number of times we would get a tail on the second round. So that means that our probability is going to be the probability of getting a head multiplied by the probability of getting a tail. So when we want something and something else to happen, we multiply the probabilities together. And again, the argument is 3/4 of the time we would get a head, and then 1/4 of that 3/4 of the time we would get a tail. So we're getting 1/4 of 3/4. This is the amount of times you'd expect to get a head, or the fraction of times you'd expect to get a head, and of that 3/4, 1/4 of that time you're going to get a tail on the second round. So then we end up with 3 out of 16 for our probability. So 3/16 of the time you're going to get a head and then a tail. Now what's the probability of getting one tail? So probability of getting one tail. Well, what's the different situations that it could lead to getting one tail? We could get a head first and then a tail, like we did here. So a head and then a tail. Or we could get a tail first and then a head. That also only gives us one tail. And this is how our probability questions can be challenging, and this is why the tree diagrams can be so helpful, because by looking out the branches of the tree, I can say, well, what meets my criteria? What does this describe? Well, I could have gotten a head and then a tail, or I could get a tail and then a head. Now, in terms of the probability, that means we need to get a head and a tail, or a head and a tail. So we know we're going to have to multiply probability of head by probability of tail. But what do we do with the fact that we have one thing or the other? Well, what we're going to do is add these up, because we're increasing the chances that this thing is going to happen. Because we have two options here, we have a higher probability of getting success, of getting what we want, of getting one tail. So that's going to be probability of getting a head times the probability of getting a tail plus the probability of getting a tail multiplied by the probability of getting a head. There's lots of brackets going on, but we can tell ourselves the story of each little piece. So that's going to be probability of getting a head is 3/4 times probability of getting a tail is 1/4 plus probability of 1/4 for the tail times the probability of 3/4 for the head. So we end up with 3/16 plus 3/16, which ends up being 6/16. And we can simplify that. It's a common factor of 2. We divide above and below by 2. And we are going to end up with 3/8 of the time. Now, what's the probability we get no heads? Well, that it doesn't immediately come to mind. What does that mean that we didn't get any heads? Well, that means that we got 2 tails. It's the only way that that could happen. So then the probability of getting 2 tails is going to be 1/4 of 1/4. So we'll write it out. Probability of getting a tail times the probability of getting a tail is going to be 1/4 times 1/4 is going to be 1/16. And then what's the probability of getting at least one tail? So at least one tail. Well, that means I could have gotten one tail or 2 tails. And let's write out how that would work. Well, one tail we actually already did out, and then 2 tails we've done out as well. So let's write out what that would look like. So we write out all of our different options, we multiply all of our fractions, and then we simplify, and 5/8 of the time we get at least one tail. This is an important caveat to this. There's another way to look at it. At least one tail would be the opposite of getting no tails. So that would be 1 minus the probability of getting no tails, which would be a head and a head. So let's write out the way we'd structure that. Pardon, I wrote that entirely incorrectly. A 3 plus 3 plus 1 is 7. So 7/16 of the time you would get at least one tail. Now, the other way to look at it would be the total minus no tails would be the same as getting at least one tail. That's another way to describe it, and that would be probability of getting 2 heads, and when you work that out, you get the same 7/16. So, let's have a look at our second example. 1/5 of the time it rains. If it rains, Sam has a 30% chance of having a jacket. If it's dry, there's a 2/5 chance Sam has a jacket. So let's draw out that situation in a tree diagram. First of all, I convert my 30% chance into 3/10 because I want to deal in fractions. And then I write out, well, it's either raining or it's dry. And then do I have a jacket? I'll write that in. So if it is raining, I have a 3/10 chance of having a jacket. That's my 30%, which means I have a 70% or 7/10 chance of not having a jacket. If it's dry, I have a 2/5 chance of having a jacket, or Sam does, and that means I have a 3/5 chance of not having a jacket. So what is the probability of it raining and Sam has a jacket? So raining and jacket. Well, that is going to be 1/5 of the time it is raining, and 3/10 of that fifth is Sam is going to have a jacket. So we want raining and jacket to happen together. So when we multiply our two fractions, we get 3/50. So 3/50 of the time, I should say, it is both raining and Sam has a jacket. And then what's the probability that Sam has a jacket just in general? Well, what are the different ways that that could happen? Well, it could be raining and Sam could have a jacket. Or it could not be raining, so it could be dry and Sam could have a jacket. So that would be raining and a jacket would be a fifth or 3/10 of 1/5, or means we're going to add this up, and dry is 4/5 and has a jacket is 2/5 when it's dry. So of the 4/5 of the time when it's dry, Sam is going to have a jacket 2/5 of that time. And when we multiply that out, we're going to get 3/50 plus 8/25. So we need to multiply above and below here by 2 in order to get the same denominator, lowest common denominator of 50, because this doesn't simplify. So I end up with 3 plus 16 all over 50, adding my numerators. So I end up with 19 out of 50 for my probabilities. And that is what we need. So when we're thinking of one thing or another, we're going to add our probabilities together. When we want one thing and another to happen, we're going to multiply them. And we've discussed where that is coming from in both cases. And you can see how you can use your tree diagrams to tell even quite a complicated story like this one. And we're able to follow our stories quite easily once we have our picture drawn. And that's what we need for now.